I would speak about manufacturing in general, though we have our ERP solution for this kind of an industry. But the essence of the discussion would be what are the best practices we can bring in manufacturing industry and how a typical ERP system or an advanced ERP system can support these kind of best practices. A very simplistic view of an organization which is running a manufacturing unit or multiple manufacturing units. And if you look at the entire value chain, if you see this diagram, in the right side, we have the order to cash cycle. That is the process which starts with collection or receiving orders and eventually translating that into sales and collecting the cash flow. On the left side, we have the procurement to pay process. That is, there's a requisition to suppliers, and there is a purchase order, there is a GRN, and finally payout to the supplier. And in the bottom, you see the accounting system, which is the receivables, payables, and the general ledger. Now, the problem that we try to face today is that in the procurement cycle, we try to reduce the lead time, that is the procurement and inventory lead time. On the ordering side, we want to reduce the order turnaround time. Now, why do we want to do it? Of course, we want to do it because by reducing the order turnaround time, we get in more cash flows. And by reducing the lead time, we reduce our working capital, which is blocked in inventory. So, but the problem is, which is happening in most of the industries today that we see, is that the right side and the left side is not very clearly connected. So they are operating fairly independently, and that is because they are different in departments in its own right. There are a lot of heuristics which are applied to see whether the inventories are the right level. But the problem is that this analysis is done in Excel sheets in a disconnected fashion. There is never a procurement that is linked to an order, and there is never an order which is taken on basis of how much you can supply. So this is, of course, the worst case scenario, but a lot of businesses are operating with these challenges. What we say is the activities in the shop floor and the management decisions in the top floor are largely disconnected. What lies in between are a bunch of Excel sheets which are prepared on heuristics, as I said, and they are prepared at a time when there is very little opportunity left for decision making because those data is collected much after the actual activity happens, and that data is not very accurately reliable. Three variations in manufacturing system that contributes the complexity that you have in running your business. So we'll start with the simple most variation on what actually makes the manufacturing system more complex and challenging. So the first variation is volume. There are some firms which operate in a market situation where the market demand or the volume is either seasonal or highly volatile. There are some markets where the volume is fairly consistent. There are two manufacturing models that come into play. One is the made to stock, another is made to order. So if your demand is consistent, you can actually make a forecast and stock your products accordingly and have a production schedule which is stocking products with a minimum buffer stock so that your annual forecast or a monthly forecast is met. So made to stock is actually the simplest, most manufacturing model that we encounter when we try to integrate the processes. The complex part is, of course, made to order, because here you actually don't stock anything or you stock very minimal. You rather wait for the customer order and then you decide whether you have the capacity to entertain that order, and you also further decide whether you produce it yourself or you subcontract it. So made to order is the first level of complexity that comes in a manufacturing system. Verticals that operate in a made to order situation is auto component, gem jewelries, civil supplies. I move to the next level of complexity that would drive your, or that would challenge your execution systems. That is variation in composition of the finished good. So by variation in composition, I mean that bill of material itself changes with every production batch. So either the mix of the raw material changes or the proportion of some catalytic component changes. Now, there are two types of manufacturing that is, again, emerges when we cater to this kind of a variation. One is discrete manufacturing, another is process manufacturing. So if the components in your production or your finished good is constant, we call it discrete manufacturing. If it varies with every batch, it is process manufacturing. Now, this is another complexity, process manufacturing, because you do not have a steady or constant costing model or a constant production model for a process manufacturing. The recipe changes with every production and it changes with every order. Now, the industry that operates in this particular, with this complexity is agrochemicals, foundries. You will be actually facing a lot of process manufacturing challenges, and of course, food and beverages. Now, I'll talk about the highest level of complexity. This is the most challenging complexity in manufacturing, that is the design variation. In a lot of industries, with every order, the design of the product itself changes. The engineering of the product is made against the order, and there's a manufacturing model that is actually drafted, which is made into execution, and finally it is produced. We call it design variation. Now, again, there are two types of design variation. If it is simpler, your design is more or less constant, but there are some parameters that are changing. We call it configured to order. But what if your design is itself very different? For example, in casting, your customer gives you different dimensions, different mix, different proportion of raw materials, catalysts, different thermal profile. There's so many things which are so different, to the extent that your manufacturing process, the processes or the routing levels through which you will make the finished good itself changes with every order. This makes your manufacturing extremely complicated. And this we call engineered to order. And the companies which are, or the verticals which are typically operate in this particular complexity area are construction business, leather and textiles. Now, why am I saying this? I am saying this because each of these complexities may exist in your firm, and there is no standard ERP that will actually take care of the complexity which matters you most, unless it is properly analyzed during the implementation process and it is seen that the main complexity is actually addressed or not. So let us see what is the role of an ERP system in handling these complexities. In a MATE, there are three parameters on which ERP or a manufacturing execution system operates. These parameters are optimized based on your business processes, and they are also integrated so that you get the actual value of the ERP in terms of visibility of your business and cost reduction. So the three parameters are the lead time of your inventory, the bill of material management, and the third is routing management. Routing is, as you would know, are the various operations which are done in a sequence that converts the product from a raw material to a finished good. Now, in a made-to-order business, what matters actually most is the lead time, the inventory lead time. That is what I am narrating from my experience, because in many of the made-to-order decisions, when a customer has placed you certain order, you have the volume of the order is a function of how much you can deliver. And that capacity analysis is an important factor. A lot of time, a firm may not have internal capacity to produce or oblige that order, and they take the decision of subcontracting. So again, if they subcontract, what is the lead time in which the subcontractor will turn around the manufacturing? That is an important factor. What is the lead time your internal systems will turn around the product is an important factor. What is the lead time in which the raw materials will be delivered? So we normally, in a made-to-order situation, we try to first optimize the lead time. In process manufacturing, where there is high variation in the bill of material, we try to come up with a system that will make the bill of material dynamic, which means that you have a system of formulations where, based on certain parameters, the system is able to advise you what is the formulation of the recipe in which your products are to be manufactured, and what would be the inventory consumption based on that formulation. Finally, in an engineer-to-order situation where the design variation is very high in the industries, what we try to optimize is the routing. Because with every design, your manufacturing operations change. And since they change, the sequence, the labor allocation, the machine allocation, they all change. So what we try to optimize is how can the routing be made more efficient in time and also in terms of overhead. When we talk about these three dynamic parameters, lead time, BOM, and routing, there are actually different parts of an ERP system that cater to these kind of variations and optimizations. And many of us must have heard about ERP, but would not have heard about the specific roles each of the modules of ERP that play in optimizing these parameters. Firstly, when your lead time is dynamic, the first system that we would like to emphasize on is the supply chain management system. So if you have a subcontractor network, or you have an internal vertical integration of production, like you have multiple units, what you would like to first integrate is the subcontractors and your internal units into a common thread of production. There you would actually track the inventory at every checkpoint, in which you can optimize the lead time and the currency of the inventory. But when your bill of material is dynamic, that is, your composition changes with every product, that is where you require an MRP, material resource planning system, that will work on the recipes that you have for various products, standard recipes, and schedule your production and raw material procurement based on those recipes. Manufacturing requirement planning is actually a system which actually automatically calculates your raw material consumption and schedules the job order and schedules the purchase order to your suppliers, so that the entire operation is actually scheduled by the system with very little human intervention. Now finally, when your routing, that is your operations, are dynamic, particularly happens in an engineer to order situation, what you actually look for is having a capacity planning system where you see which machines can be applied at what idle time. So you require a capacity planning system so that you can have a more dynamic routing system. You can make the system look for idle times from the calendar of every machine and allocate operations in those machines based on every order that you get. So you see that every module of ERP has a very scientific role to play based on the complexity that you have in your manufacturing system. And it's highly mathematical and scientific. And though we have been managing it with a lot of human intervention until now, it is very much possible for a system to actually manage it more efficiently in a planned manner. I will talk about a more easier aspect of ERP system, which is the software aspect of ERP system. We have in TCS engaged with multiple customers from small market to mid market and even large accounts like General Electric. And we have seen diverse manufacturing systems, B2B systems, supply chain systems. And often we have seen that as much the role that system has to play in optimizing the business, the role of the management and the people is even no less. What I mean to say is how well you will be able to use the ERP is a function of how well you are ready to change the style in which you have been managing your company. ERP is a system which requires discipline, it requires a lot of commitment from the management, and of course it has a true benefits once one believes on those benefits and is ready to adopt the changes that are required in the organization. What top management looks for from an ERP is real-time dashboards. They want real-time information system so that on basis of that, they can do two things. One is they can control the organization for better discipline and trust. And number two is that they are provided with more management information system to change the organization policies and the processes. But the problem is these dashboards are often, we find, is not being useful to a lot of management bodies of many firms because they are not in line with the processes which are deployed. So I will talk about some of the reasons why we require dashboards and what is the typical culture in which these are dealt with. I know most of us here are belonging from the small and medium industries. Many of the firms are in a flux because they are growing, and with growth, they feel the need of changing their management style. They feel the need of changing the processes and the way the organization functions. Sometimes they also feel the need of changing the organization culture. I am touching upon this because this has a role to play in the ERP implementation and also in your choice of the systems. We have come across two management styles in ERP implementation. And I would first at the outset say that both are equally good or bad in adopting an ERP system, but there are certain pitfalls in each of the styles which we should be concerned about. Firstly, one is the management by control. That is, there are some firms which would like to manage an organization with more control. Typically, it is seen in family-run businesses, which is growing very fast, and there is a concern about trust, and there is a concern about whether the information which is being flowed or which is being flown across is accurately provided or not, or whether there are proper segregation of duties within the organization that ensures that there is very little flouting of the policies. Now, management by control typically is a style where the organization management intervenes in the activities and tasks of the people so that they ensure that they have more preventive controls against any kind of exception. The other style of management is management by exception, which is that the management is relatively gives a free hand to the people, but keeps a close watch on certain dashboards and reports to see whether there has been any exceptions which has been occurred, which can give him an idea to either change the policy or bring in better control. So management by control companies normally have a lot of divided departments, and these departments are very active in escalating and alerting the management, and they do it in their own independent threads without collaborating much. The management by exception firms, there we find departments more talking to each other and more collaborating. Management by control, on the other hand, the management tracks activities, whereas by exception, the management tracks results, which is an important factor. Now, what does it mean when a firm has a management that tracks activities? It means in ERP that you will bring in more workflows. By workflows, we mean that every transaction will go through an approval route. So you raise a purchase order that is approved in 3 levels. Even the managing director would like to approve a purchase order which may be an order value of 40 or 50,000 rupees. On the other hand, management by exception are those companies which will actually have less number of workflows, but will have more reports to audit and oversee whether the operations have happened as per the policy or not. Now, this is the kind of dichotomy that we face in ERP implementations, whether in a manufacturing execution system or an integrated ERP system, whether we should have more workflows which will connect the management in every transaction, or we have better dashboards which will inform the management on every processes on a time-to-time basis. Now, we claim that either culture is fine because each culture has its own merit and addresses certain concerns by the management. There is a saying by Peter Drucker that company cultures are like country cultures. Never try to change one. Live with what you have. But what we see is that in management by control firms, 90% of the ERP or manufacturing execution systems fail because they have implemented the wrong workflows. Either the approver is not the actual decision maker, or the decision maker is not accounted for in very critical approvals. On the management by exception, we see that the maximum ERP fail due to the wrong MIS being presented to the management, despite a lot of efforts being made in integrating the processes. To summarize, what I mean to say is that there is no standard model that defines you best. You are from an industry which has various levels of complexity. One complexity is there are some firms which experience variation in demand and they adopt a made-to-order manufacturing model. There are some firms which experience dynamic changes in the bill of material and composition, and they adopt a process manufacturing model. And there are some firms where the engineering and the design activity itself is done for every new order that comes in, and they actually have an engineer-to-order production model. Now, each of these complexities have specific roles to play by the ERP system. May they be a supply chain management system or a materials requirement planning system or a dynamic bill of material management system by MRP. These systems have to be addressed and implemented based on the level of complexity that is there in your organization. Of course, I mean that there is no ERP which is a silver bullet. there is a consultation exercise required to understand your processes, what are the complexities, and what are the best parts of the ERP that is required, and what is the level of integration that is required. Finally, after the integration is done, you need the right dashboard to be given by the management and the right workflows so that you intervene in the areas where you perceive risks. Now, the choice between the workflows and dashboards, these play a complementary role. What you are intervening by workflows, but that is the transactions where you are taking approval from the management, you actually don't need a dashboard because you have already taken the preventive measures. But the places where you have given a free hand to people based on certain policies, you require reports and dashboards to actually see whether those policies need to undergo change. And that is precisely the role of MIS. Now, ERP has to strike a balance between this control, that is workflow, and efficiency, that is dashboards. And that is actually a function of your management style. So in a typical ERP consulting phase, we not only analyze the business process, the manufacturing model, but also how the organization is run, what are the typical mindset or what are the specific mindset of the management of that firm, what kind of culture that runs the manufacturing unit and also in the management of the firm, and then see what is the right mix of various features of the ERP that would go into it. So I'm talking from the perspective of any ERP implementation. I'm sure any vendor would follow this as the ideal process, not from the perspective of a specific ERP.